Hello children, before moving ahead, we need to learn differentiation and integration as they will help in solving several numericals in physics. So let us start with differentiation. The first question is why to study differential calculus? The purpose of differential calculus is to study the increase or decrease in a quantity with respect to another quantity on which it depends, varies independently. So let us understand what does this statement mean. Consider a particle is moving along this curve in 2D Cartesian coordinate plane. At any moment, its position is given by two variables known as coordinates. X is independent variable and y is dependent variable. Value of y depends on x and it is given by y is equal to function of x. For each and every value of x, there will be a unique y. So in differential calculus, we study how the value of y varies when x varies independently. Now let us see two important terms. First one is average rate of change. Consider 2 points A and B whose coordinates are x1 y1 and x2 y2. So average rate of change is defined as average rate of change in y with respect to x in this interval x1 to x2, and it is given as change in y upon change in x, that is y2 minus y1 minus y1 upon x2 minus x1 x2 minus x1, and that is equal to delta y upon delta x. This is delta y, this is delta x, and that is equal to slope of chord AB, slope of chord AB. Second term is instantaneous rate of change. Consider delta to be very small so that this interval shrinks to a point x. Then instantaneous rate of change is given by dy by dx and it is equal to tan theta, where theta is the angle that tangent at P makes with the positive x-axis. Dy by dx can be calculated by first derivative of function y is equal to fx, and it is denoted by dy by dx is equal to y dash is equal to f dash x. Second order derivative can be written as d square y upon dx square is equal to y double dash is equal to f double dash x. Similarly, we can write higher order derivatives. Second order derivative onwards is called as higher order derivatives. Let us see first derivatives of commonly used functions. First one is y is equal to k, where k is a constant. So dy by dx is equal to 0. Second one, y is equal to x to power n. dy by dx is equal to n x to power n minus 1. It is easy to remember, put n here and reduce the power of x by 1. So it will be n x to power n minus 1. Third one, y is equal to e to power x, exponential function. dy by dx is e to power x, same, no change. Y is equal to ln x. ln is natural log on the base e. So dy by dx is 1 by x. Fifth one, y is equal to sine x. Now here onwards, all the trigonometric functions. Y is equal to sine x. So dy by dx is cos x. Y is equal to cos x. dy by dx is equal to minus sine x. Y is equal to tan x. dy by dx is sec square x. Y is equal to cot x. dy by dx is minus cosec square x. Y is equal to sec x. dy by dx is equal to sec x tan x. Y is equal to cosec x, dy by dx is equal to minus cosec x cot x. You may note down the table and memorize it. Now let us see rules for differentiation. First one is, if function is multiplied by a constant y is equal to k times fx, then y dash will be k times f dash x. Means you have to take the derivative of the function and multiply with the constant. Let us see this example. Y is equal to 2x square. Then y dash will be equal to 2 times of, let us take the derivative of this function, d by dx of x square. You know that d by dx of x to power n is equal to n x to power n minus 1. Here n is equal to 2. So y dash is equal to 2 into n, means 2 x to power n minus 1 means x to power 2 minus 1, and that is equal to 2 into 2, 4 into x to power 2 minus 1, that is 1. So y dash is equal to 4x. Second one is addition or subtraction of two functions. We will see addition first. Y is equal to fx plus gx. Fx and gx are two functions. So y dash will be equal to f dash x plus g dash x. Means we have to take derivatives of two functions and add them. Let us see this example. Y is equal to 2x square plus e to power x. Then y dash will be equal to derivative of this function will be like this. So the result is 4x plus derivative of this function e to power x. You know d by dx of e to power x is same as e to power x. So this is the answer. Let us see the subtraction. Y is equal to fx minus gx. Fx is one function, gx is another function. Then similarly, y dash x is equal to f dash x minus g dash x. Let us see this example. Y dash will be equal to derivative of this function will be 4x as we have already done minus ln x. So derivative of ln x, you remember from the previous table, it is 1 by x. So y dash will be 4x minus 1 by x. Third one, multiplication of two functions, also known as product rule. Y is equal to fx into gx. Fx is first function and gx is second function. Then y dash will be first function into derivative of second function plus second function into derivative of first function. Let us see this example. Y is equal to x sine x. So fx is equal to x, gx is equal to sine x. So y dash will be equal to first function x into derivative of second function d by dx of sine x plus second function sine x into derivative of first function d by dx of x. That will be equal to x into derivative of sine x will be cos x cos x plus sin x into derivative of x will be equal to 1. So the answer will be y dash is equal to x cos x plus sin x. Fourth one is division of two functions, also known as division rule. Y is equal to fx upon gx. Fx and gx are two functions. Then y dash is equal to gx into f dash x minus fx into g dash x divided by gx whole square. Let us see this example. Y is equal to cos x upon x. Here fx is equal to cos x and gx is equal to x. So y dash will be equal to gx into f dash x. Gx is x into f dash x will be d by dx of cos x minus fx into g dash x. Fx is cos x into g dash x can be written as d by dx of x divided by gx whole square x square. So it will be x into d by dx of cos x will be minus sin x minus cos x. D by dx of x will be 1 divided by x square. So the answer is minus x sin x minus cos x divided by x square. Fifth one, function of functions, also known as chain rule. Suppose there is a function y is equal to fx and another function x equal to ft. Then dy by dt is equal to dy by dx into dx by dt. dy by dx can be calculated from here and dx by dt can be calculated from here. Let us see this example. Y is equal to 4 sine 3x. Assume t is equal to 3x. Then dt by dx is equal to 3 times d by dx of x, and that is equal to 3 d by dx of x is 1. So dt by dx is equal to 3. We have to calculate dy by dx from here. So dy by dx is equal to dy by dt into dt by dx. We will calculate dy by dt from here. So it can be written as y is equal to 4 sine, and we have assumed t is equal to 3x. So sine t, 4 sine t. So dy by dt is equal to 4 into d by dt of sine t, and that is equal to d by dt of sine t is cos t. So we will substitute these two values, this value and this value here. Dy by dt, just we have calculated, that is equal to 4 cos t. In place of t, we will put back 3x. 4 cos 3x into dt by dx. dt by dx is 3 into 3. So 4 into 3, that is 12 cos 3x. That will be equal to y dash or dy by dx. Now let us see maxima and minima of a function. Consider a particle is moving along this curve in 2D Cartesian coordinate plane. At point A, it is at top, and at point B, it is at bottom. Point A is maxima and point B is minima. Draw a tangent at point A and another tangent at point B. They will be parallel to x-axis, means their slope will be 0. Their slope will be given by tan theta, where theta is the angle they make with the positive x-axis. In these cases, theta is 0 degree, so y dash, which is given by the slope of tangent, will be 0 in both the cases, maxima and minima. So in maxima and minima, dy by dx is equal to 0. Consider 2 points A1 and A2. A1 is at left of A and A2 is at right of A. Now draw tangents at A1 and A2. So tangent at A1 will have positive slope. At A it will have 0 slope, and at A2 it will have negative slope. Means rate of change of slope is decreasing from positive to 0, 0 to negative. So rate of change of slope is given by d by dx of dy by dx, where dy by dx is slope. So rate of change of slope, which is double derivative of y, means d square y upon dx square, will be negative in case of maxima. So for maxima, there are two conditions. Dy by dx is equal to 0 and d square y upon dx square is less than 0. Similarly, consider 2 points B1 and B2. B1 is at left of B and B2 is at right of B. Draw tangents at B1 and B2. Slope of tangent at B1 will be negative. At B it is 0 and at B2 it will be positive. Means rate of change of slope is going from negative to 0, 0 to positive. So it is increasing, and rate of change of slope is given by d by dx of dy by dx, which is nothing but double derivative of y, means d square y upon dx square. So in case of minima, d square y upon dx square is greater than 0. So you need to remember these conditions for maxima and minima. Now let us see integration. Integration is the reverse process of differentiation. By integration, we can find a function whose differentiation is known. This is integration sign. So integration of fx dx is equal to fx plus c. If you differentiate this part, you will get this function. Let us see few basic formula of integration. First one is integration of x to power n dx, that is equal to x to power n plus 1 upon n plus 1 plus c. C is constant of integration. Second one, integration of ax plus b to power n dx, that is equal to ax plus b to power n plus 1 upon a times n plus 1 plus c. Third one, integration of e to power x dx is e to power x plus c. Fourth one, integration of e to power ax plus b dx is equal to e to power ax plus b upon a plus c. Fifth one, integration of 1 by x dx is equal to ln x plus c. Sixth one, integration of 1 by ax plus b dx is ln ax plus b upon a plus c. Seventh one, integration of sin x dx is equal to minus cos x plus c. Eighth one, integration of sin ax plus b dx is equal to minus cos ax plus b upon a plus c. Ninth one, integration of cos x dx is equal to sin x plus c. 10th one, integration of cos ax plus b dx is equal to sin ax plus b upon a plus c. 11th one, integration of sec square x dx is equal to tan x plus c. And the last one, integration of sec square ax plus b dx is equal to tan ax plus b upon a plus c. You can note them down and memorize. The cross verification is, if you do the differentiation of right side, you will get this function. For example, sin x plus c. When you do differentiation of this, you will get cos x plus 0, means cos x. Now let us see some questions on integration. First one is integration of 2x to power 4 dx. That is equal to, we can take 2 out. So 2 integration of x to power 4 dx. And we know that integration of x to power n dx is equal to x to power n plus 1 upon n plus 1 plus c. So it is equal to 2. Here n is equal to 4. So it will be 2 into x to power 4 plus 1, means x to power 5 upon 5 plus c. So the answer is 2x to power 5 upon 5 plus c. Second question, integration of x plus 1 by x dx. So we can write it as integration of x dx plus integration of 1 by x dx. Integration of x dx can be figured out by this. Put n is equal to 1. So integration of x dx will be equal to x to power 1 plus 1 upon 1 plus 1, means x square by 2. So it will be x square by 2 plus. Integration of 1 by x dx is equal to ln x plus constant of integration. So integration of x plus 1 by x dx is equal to x square by 2 plus ln x plus c. Third question, integration of sine 2x plus 3 dx. We know the formula that integration of sine ax plus b dx is equal to minus cos ax plus b upon a plus c. Now putting the value a is equal to 2 and b is equal to 3. So integration of sine 2x plus 3 dx will be equal to minus cos 2x plus 3 upon 2 plus c. Now let us see definite integration. When a function is integrated between a lower limit and an upper limit, it is called as definite integration. So it is represented as integration sign. This is lower limit, this is upper limit. Fx dx is equal to fb minus fa. Let us see one example. Integration of 3x square dx between x equal to 1 and x equal to 3. We know that integration of x to power n dx is equal to x to power n plus 1 upon n plus 1 plus c. So we can write it as 3 integration of x square dx between 1 to 3. So it will be equal to integration of x square dx will be, put n is equal to 2. So x to power 3 upon 3. X to power 3 upon 3 plus c. Now put the limits 1 to 3. So we can evaluate this as, put the upper limit first. So x equal to 3. So 3 cube will be 27. 27 upon 3 will be 9. So it will be 9 plus c minus lower limit. Put x equal to 1. So it will be 1 by 3 plus c. 1 by 3 plus c. So it will be equal to 3 into 9 plus c minus 1 by 3 minus c. So c plus c and minus c will get cancelled out. So it will be 9 minus 1 by 3. So it will be equal to, take 3 as LCM, 3 9s are 27 minus 1. So it will be 3 into 26 upon 3. and that will be 26. Now let us see area under a curve and x-axis. Consider this curve is given by y is equal to fx. We have to find out area between this curve and x-axis between the limits x equal to a and x equal to b, means this area. Consider a very small strip of width dx and height y. So area of the strip will be given by dA is equal to y into dx, considering it as a rectangle of very small width and height y. So area will be given by integration of dA between the limits x equal to a and x equal to b. So we can write it as area is equal to a to b, dA can be replaced by y dx. Average value of a continuous function in an interval. Consider the function y is equal to fx and interval is x lies between a to b. So the lower limit is a and upper limit is b. So average value of y is given by the formula integration of y dx between limits a and b upon integration of dx between limits a and b. So it will be equal to integration of y dx between limit a and b, and this will be equal to b minus a. How? Because integration of dx means integration of 1 dx, that will be equal to x, and when you put the limit, so it will be higher limit b minus lower limit a, so its value will be b minus a. That's what it is written here. So average value can be calculated by this formula. Let us see this example. Determine the average value of y is equal to x plus 4 in the interval x lies between 0 to 2. Y average is equal to integration of y dx, means x plus 4 dx between the limits 0 to 2, 0 to 2, divide by b minus a, means 2 minus 0. So it will be integration of x plus 4 dx will be x square by 2 plus 4x plus c. Now put the limits 0 to 2 divided by 2. So when you put x equal to 2, it will be 2 square. 4 upon 2 means 2 plus 4 into 2 means 8. So 2 plus 8 plus c, minus when you put lower limits, it will be 0 plus 0 plus c, that is equal to c divided by 2, means 2 plus 8, 10 plus c minus c divided by 2, that is 10 by 2 equal to 5. In the next video, we will start this chapter. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.